All right, so we were just about ready to start filling out this so we can find the surface area of this cylinder here. So 2 times 3.14 times r being 1.2 inches squared plus 2 times 3.14 times r, again 1.2 inches, and then a height of 3.2 inches. And again, we get the calculator out and do a little arithmetic on that. And this piece will be 9.0432. And the other piece is 24.1152, and then we add those up and we will get this. And yeah, as I said before, follow the directions that they give you for rounding. Typically we are going to round to the 10th place, so you'll be looking here, and the 100th place will help you decide whether you round up or if you just chop that off. So 5 tells us to round up, so approximately 33.2, and then remember, because it's an area measurement, inches squared, surface area of that cylinder. All right, I want to look at, okay, so we're going to quick do a the sphere, and so pretending we're having a golf ball with a diameter 4.2 centimeters. So diameter, remember, that means we're going all the way across there through the center. And like I said before, it's a good habit to just get into finding the radius right away. So cut that in half, 2.1 centimeters. And the reason we're going to do that is because surface area and volume formulas for a sphere only use the radius. We want that halfway across distance. All right, so the two formulas, 4 pi r squared, and then volume is 4/3 pi r cubed. All right, so surface area for here. So 4 times 3.14 times our radius, 2.1 squared. And it's going to give me 55.3896. And again, round to the nearest tenth. So I look at the hundredths place. That tells me to round up. So surface area is approximately 55.4. And then centimeters squared, because it is an area measurement. We're covering the sphere. We're painting it. Volume. A very similar formula. Again, we only need the radius. So 4/3 times 3.14 times that radius. This time it's cubed because we're looking at volume, so we're talking about cubic units. And this is going to be, let's see here. Is 38.7727, and I suspect that that continues to repeat. Again, we're still going to be just rounding probably to the nearest tenth, so volume is approximately 38.8, and here centimeters cubed. So you cannot compare these directly because this one is covering things and this one is filling things up. So remember, if we look back on the little box, you know, if we cover the top of this, that's going to be part of our surface area. If we figure out how many of these tiny dice it would take to fill it up, that would be looking at volume. So you cannot compare those directly. They're a two-dimensional idea and a three-dimensional idea. Flipping over to the next page, so volume, we did do some volumes already. Let me just double check what I'm thinking of here. No, we did not. Okay, so volume for a couple of these figures. So let's hit the rectangular prism here. So my length and width are 0.8 feet, and then this is going to be my height. Now, you do need to just double check. Like, you'll notice here that we've got feet here and yards here. Sometimes they will switch up your labels. Make sure that you make them all the same. So I am going to, let's see, I am going to multiply the yards by 3 to get that there are 7.5 feet in that height. And now it will all be in feet. So I have a consistent unit. So volume, length times width times height. So 0.8 times 0.8 times 7.5. Is going to give me 4.8. And then that's feet cubed because we are looking at volume. All right, and then a cylinder, and then we will call this good. So here's our cylinder. It's on the side now. So our 2 circular bases are on these edges, and then we have the around. So we still want to figure out how much does it take to fill this up. So we look at that volume formula, which is going to be pi r squared, that base, times the height. So thinking about taking a very small slice of this and then figuring out I have 1 millimeter worth of slices to figure out how much space this takes up in the real world. We are given the radius directly and we have the height. So we can go ahead and substitute into that formula. And we will get is 12.56, and that is millimeters cubed. Again, remembering we're talking about a volume idea. And especially in the case of my little purple canister here, we're going to figure out how many dice does it take to completely fill up this container. Those look like they're stuck. That's all right. But you get the idea. We're figuring out how do we fill this up, and we're using cubes to do that. And we're doing that geometrically too, not just with the fact that I have dice in this little container. And that is, again, why it is a cubic unit for that. How many cubes does it take to fill that up? All right, hopefully this will get you guys taken care of on the geometry stuff. Please let me know if you do have any other questions. So that finished us up on page 7.